إذا section 2 we are interested in نرجع للcomplex numbers. شفناها math 1 but another point of view, polar form of a complex number. So what's this? So just to recall, a complex number is the sum of a real part and an imaginary part. Here نرجع ل I definition اللي هي I root minus 1. This is the imaginary unit, or I square equals minus 1, as we have seen in math 1. Okay? So I imaginary number, A the real part, imaginary part, and so on. This is called the standard form or the rectangular form of Z. This chapter, the aim is to write another form, important in practice, called the polar form. So هذا the Cartesian coordinate, the real axis, the imaginary axis. هذا اللي متعودين به. هذه A, هذه B, هذا A plus BI. We'll now define what we call the modulus of a complex number. So if Z is a complex number in standard form X plus YI, its modulus is root X square plus Y square. يشبه الحاجة شفناها في الفاكتورز من هنا. الرمز هذا باقي نستخدمه، استخدمناه في الفاكتورز هذا، سميناه magnitude of a vector. Modulus of a complex numbers. Same formula, more or less, but different names. Okay? Then, more or less same meaning. What this distance, this length, the distance between this complex number and the origin. These are the modulus. Okay? And we have only an angle here, theta, between the positive x-axis and this side. هذا نسميه the argument. The argument of a complex number. Then complex number عندنا modulus وعندنا argument for complex number. For vectors سميناهم magnitude and direction angle. This is for vectors. Okay, but same formula. We still use tan inverse of absolute value of y over x to retrieve the reference angle, and depending on the quadrant where the terminal side is, we use one of these four formulas. Okay, same formula, no new formula. لكن الاسم يتغير بكاف. Okay, ممكن يعطيكم fill in the blanks. For complex number, it's called modulus. For complex number, it's called argument. Whereas for vector, we use magnitude and direction angle. Okay, but more or less the same quantities. Okay, so if we call R the magnitude or the modulus, if theta is the argument, these are the relationship. Tan theta is y over x, sine theta is y over r. Now y here r sine theta, x here r cosine theta. Okay. I have this form called the polar form. So in the polar form, we use the modulus and the argument to express the complex number. And this is the relationship between the modulus and the argument, how to find the horizontal, not horizontal, how to find here the real part and the imaginary part of the complex number. So we use sine for the imaginary part, we use cosine for the real part for the complex number. We use sine for the vertical component and cosine for the horizontal component for a vector multiplied by the modulus. Okay? And sometimes to simplify, we use this notation, RCIS. What does it mean? RCIS theta, C for cosine, this is the real part, plus I, S for sine, and this is the imaginary part. Okay? And this is called the polar form. So a complex number is defined by R and theta, its modulus and its argument. If we know this angle and this distance, we have exactly the complex number on the complex plane. Okay? So write the following complex number in a standard form. then كيف نمشي من البولار فورم للستاندرد فورم؟ ايش قلنا؟ 3is 60 degrees شو معناها؟
3 equals R.
3 cosine 60 plus I sine 60. Cosine 60 is half. Sine 60 is root 3 over 2. So this is this complex number in standard form. For this one, the same 6 cosine 5 pi over 6 plus I 6. I forget here 3. Huh? Be careful. Huh? 6 sine 5 pi over 6. 5 pi over 6 من موجودة in which quadrant? It's in quadrant 2. So it's minus 6 root 3 over 2 plus I 6 times half. So it's minus 3 root 3 plus 3 I. This is this complex number in standard form. Here it's 5 cosine pi plus I sine pi. Cosine pi become minus 1. Sine pi
0.
0. So this is minus 5. This is a real number. Okay? Pi, so we are here on the real axis. So this is minus 5. Okay? So this is how to convert from polar or trigonometric form. It's called polar form or trigonometric form. We are using trigonometric function, sine, cosine, and tan. So from a standard form to polar form, it's easy. Just plot the complex number in the complex plane to find the quadrant, calculate the modulus, and calculate the reference angle using tan inverse. Okay? Of course, the pure imaginary numbers lies on the y-axis when we have the argument 90 degrees or 270 degrees, we get pure imaginary number, no real part equals 0. And to write this complex number in polar form, we plot the complex number. We نيجي هذا 2 minus 2i.
Quadrant 4.
We are in quadrant 4. So the modulus will be root 2 square plus minus 2 square. It's 2 root 2. The reference angle is tan inverse 2 over 2. It's 45 degrees. The angle theta is 360 degrees minus 45, 315 degrees. So the complex number in polar form هيكون 2 root 2 CIS 315 degrees. Is it clear?
دكتور
Yes.
ممكن يعطيني equation يكون الزي ما هو في standard form وأنا أحتاج إني أرجع standard form. مثلا I root 3 بالنسبة للبي يكون في البداية وال1 يكون في اليمين.
اوكي فهمتك. هاي معناها يعطيك كده. ها هاي انت الافضل ستاندرد فورم باش ما تختار دائما الريال بارت هي الاولى. اوكي this is A, this is B, this is X, this is Y in your formula always. اوكي ترتيب مهم. you are right. بعض الاحيان يخبص يعطيك يكتبها لك كده لكن انت لازم بالترتيب. ها important remark. yeah you are right. لازم تكتبها كده حتى ما تخطئ. اتفقنا؟ so هذا الواي وهذا الاكس. اوكي دايما الاكس هي الريال بارت، الواي هي الايماجينري بارت always. اذا هنا we are in quadrant 1 root 3. so we are in Q1. so the modulus is 1 plus 3 is 2 and the argument theta هنا هي نفسها alpha هي tan inverse of root 3 over 1 يعني كم هذه tan inverse of root 3 هي 60. so z هي 2 CIS 60 degrees. So the last one هذا I وين موجود؟ وين I؟
y axis.
من هنا 0 1. إذا كم الارجيومنت هنا؟ indirectly 90 degrees. كم المودولس؟ It's root 0 square plus 1 square, it's 1. It's the unit. I is unit, modulus 1. Okay? It's the unit. So, modulus, quadrant, reference angle, and theta, and trigonometric. Modulus, reference angle, quadrant, angle theta, and polar form. Modulus, we are on the positive y-axis, 90, trigonometric form, CIS 90. This is I. I is CIS 90 degrees. Okay, can keep this in mind. Okay, I think it's clear. Now, what is the interest of the polar form? One of the interest, and مزايا كثيرة is when we multiply or we divide complex numbers. هنا المultiplication والdivision تصير really easy. ليش؟ لأنه if we have the polar form of two complex number, to make the product, it's just the product of the modulus, CIS, the sum of the argument. When we divide, it's just the ratio of the modulus, CIS, the difference of the arguments directly. So تصير multiplication will division easy. Okay. هنا نشوف مثال. Z1 Z2. شو راح تكون Z1 Z2؟
24.
24 منين جات؟ 12 times 2
CIS 300.
CIS 300 225 plus 75. What is the quotient?
6 CIS
6 CIS
150.
150 degrees. Becomes really easy directly. Okay, نتذكر using standard form. مثلا إذا عندك إذا نتذكر Z1 plus I و Z2 3 plus 2I لازم تكتبوا standard form. You multiply by the conjugate. You multiply 3 minus 2I plus 3I plus 2 over 9 plus 4. It's 5 plus I over 13. So the division is quite long using standard form. So here it's more or less straightforward. Okay, it's really easy. Okay, so قال يكتب عندنا standard form. ترجع تحسب cosine 300 والsine 300 and you get it in standard form. هنا نفس الشيء, this in polar form. بعدين تحسب cosine and sine of the angle and you get the standard form. But the most interesting thing is the power. So أنت Z cube هي Z times Z times Z. You have to multiply Z 3 times. Z power 10, Z times Z times Z times Z 10 times. You will see that using polar form, تصير the power of a complex number very, very easy. This is called the Moivre theorem. This is the mathematician who discovered this. Raising a complex number to any power is really easy in polar form. You have just to raise the modulus to the power n and you multiply the argument by n. What does it mean? What is Z1 to the 6 here? It's nothing else than root 3 power 6 CIS 6 times 25. That's it. It's 27 CIS 150 degrees. إذا ما كان عندنا polar form لازم تبقى تضرب Z1 times Z1 times Z1 times Z1 very long. Whereas with polar form it's in seconds by hand we can retrieve it. بعدين in rectangular form it's just cosine 150 plus I 27 sine 150 وكوساين 150 هي minus root 3 over 2 وساين 150 هي half. Z2 power 12 إذن هي 2 power 12 CIS 600 degrees. That's it. Okay, so it's 2 power 12 cosine 600 هي نفسها ممكن تنقص 360 2 باي كم تعطينا 240. Okay, so it's 212 cosine 240 plus I 212 sine 240. 240 هذه وين تجي in which quadrant? In quadrant 3 صح؟ Z2 power 12 over Z1 power 6 is nothing else than 2 power 12 CIS 240 over 27 CIS 150. So it's 212 over 27 CIS 90 degrees. وش قلنا على CIS 90 degrees؟
cosine 90 plus
أي
sine 90.
إذا كم إذا تحسبهاش تعطيك
0 plus I.
إذا
0
CIS
plus
90
I.
هي I. إذا هذه هي 2 to the power 12 over 27 I. Okay, so this is the interest of one of the interests. It's very important in practice. Like in making powers of complex numbers an easy task, very quick task. So more or less, this is what we have today. So it allows us to draw this magnificent figures. These are powers of complex numbers. Okay, we can discuss this during the next session. And for complex numbers عندنا المودولس عندنا الارجيومنت كيف تروح من standard form للpolar form and vice versa, and how to multiply, how to divide, how to take powers of complex numbers. Really easy using polar forms.